For me, it's a pleasure to be at the DevSecCon as a sponsor, as a speaker. So this is me. I'm just a software developer from Intelligent Security, and this talk is not going to be about DevSecOps, SecDevOps, whatever ops ideas, approaches, tools into the software delivery pipeline. It's going to be about infrastructure delivery. Infrastructure for us is mainly focused on servers, databases, firewalls, networks, etc. Because just a reminder, software runs on the top of an infrastructure. So from DevOps perspective, a preliminary infrastructure-related buzzwords, the good parts of that is that infrastructure can be automatic delivery and provision it. We have a lot of tools for making immutable by means of containers. We can apply several approaches, like, for example, from pits to cattles and something like. And we can have a lot of kind of infrastructure, like physical, virtual. We can make a lot of combinations. So it's very cool. It's very cool from DevOps perspective because we have a lot of tooling, okay? So the ugly parts, and not just for DevOps perspective, just for wherever perspective really, is that all that are related with security, okay? Security compliances, firewalling, rapid threat containment, etc. Because it's complicated, well, could be a reason, but it's not a good reason. So let's see why. This is a brief description, very brief, about what is the application delivery pipeline. We can separate on software delivery, infrastructure delivery, and we want to go to application to live to production as soon as possible. So we can split infrastructure delivery on server, container services, and other related to the network infrastructure nodes, okay? So let's see. Software delivery. Across software delivery, infrastructure, network, whatever, application delivery, it's mainly a complex process because it involves a lot of people from different teams. These teams are mainly silos with different culture, with different way to do the things. So it's a very complex communication between them, and it's always ruled by means of several ticketing systems or workflow system, whatever, okay? So in software delivery, when we want to make a push of a software component into the pipeline, we have a lot of tools from the DevOps perspective. We have tools for making source code better as possible, testing, deploying, etc., monitoring. And a few years ago, with the appearance of the DevSecOps movement, there exists a lot of tooling for covering all the steps of the software delivery. Like, for example, you know, BDD security, a plugin for Jenkins, or, well, for example, Sonatype with the Nexus firewall for checking vulnerabilities on artifacts or whatever. There's a lot of good ideas, good tools, good approaches for software delivery. So, okay, it's fine. What happened in the infrastructure and in the network delivery? Well, here DevOps came to rescue, and every process that has to be validated and reviewed by people now has tooling support, more or less. So we have, for example, configuration management tools like Puppet, Chef, Ansible, etc. We can have containers for making mutable infrastructures like Docker, Kubernetes, etc. And a lot of, okay? So cool too. Well, and what happened with the network? Well, with the network, it's happening something similar because there is another movement that goes from networks very coupled to vendors, so network to code movement. So this is the NetOps movement that are providing solutions in the top of these devices, in the top of the APIs that the devices provides, like, for example, the firewalls, like vendor APIs from Juniper, Palo Alto, Cisco, Arista, etc., or ad hoc scripting solutions or libraries like NetMiko, Paramiko, or the combination of several tools like Napalm that provides a structural layer for pushing configuration on firewalls by means of Ansible, And of course, with the appearance of the software-defined networking movement and the SDNs controllers, it could be very easy to deliver the infrastructure, but just deliver. So what happens when we have to do the same thing that we're doing on software delivery, when we have to do security validations about vulnerabilities or something like, or compliances on the infrastructure delivery? Well, it's quite difficult to find a solution to have support for this task. In addition, this stage is more or less what has more bottleneck, because it is mainly focused on a process like this. It's just an example, could be vary depending on the company, but more or less there exist several teams like application owner, risk teams, SecOps teams, okay? And the application owner make a request onto a workflow ticketing system like Jira, Remedy, or whatever, saying, hey, I want visibility across this service and this another service because I'm using on my application development. So this is received by the risk assessment, so the risk team, and check the risk assessment and say, maybe yes, maybe no. But this decision could take some days, could take some hours, and we are from the DevOps perspective, it doesn't make sense. So maybe it could be approved, it's scheduled to make all the changes in all the firewalls, for example, for the SecOps team. And what happened, we have a huge infrastructure with more than 100 devices. It's very difficult to apply changes in all of them and to analyze what will be involved in the change. So this step could have more or less between weeks and months to be applied. So, and when we do that, the SecOps team delivers the change, and you have to test that all is okay. What happened here? There is a collateral damage here, because you can test that your change is okay, but you could be making a historic degradation of your policy rules, because you have done things that make that your request could work, but maybe you are breaking other things, okay? So risk teams are periodically making policy cleanups operations to make that all go good. So this is really the bottleneck, and it doesn't make sense from the DevOps perspective. So that and this, they have no product yet for tooling these stages, makes that there exists a real and painful bottleneck on the infrastructure delivery. So recapitulating the problems, it's a high manual process, involve a lot of teams with different cultures, or silos. You know, DevOps think about SecOps, the doctor no, because always say no to something. And life with the problem is not an option, because it's complicated security. Yeah, it's complicated, but it's not an option to live with that problems. You cannot apply the security by optimism and prior approach, you know, hoping that nobody hacks you, okay? So what we want is a solution for that increase our agility as fast as possible, do a cost reduction, because in the previous slide we see a process that is more or less from weeks to months, and is very painful in cost, and better risk controls, okay? We cannot live with the option, with the problem as an option. So, okay, DevSecOps to the rescue. Why not to apply the same things, the same ideas that are applying on the software delivery on this infrastructure delivery, in network delivery? So, in application delivery, DevSecOps say, A, apply the shift to the left paradigm. This is test as soon as possible, okay? So, okay, if I have to test my network needs, the first I have to do when I am defining the application is to define my network needs. And if I could define it as code, that's better. So SecOps, same thing. So define your security rules as code, and risk, define your compliance. So when we say network, security rules, compliances, the first word that comes to my mind is firewall policy. Okay, whoa, whoa. Not too fast. Are you talking to me that you have to write firewall policies? Firewall policies are painful, are difficult, make a lot of noise, etc., etc., etc. Okay, so are you crazy? No, because you are thinking about how to write these firewall policies, and I say, write what you need, abstract all the things, not say how to do that, say what do you want. So it's easy that any application owner could say something like, I need to consume several servers, or I need to provide several services across the network. And here I have no idea which devices are involved, how is my network, and so on. So from SecOps, you can say, hey, if you are going to deliver an application to the users, user network has to see app servers, okay? Simple. So risk teams say, okay, by all the traffic that goes across this has to be by TCP 443 or TCP 80, okay? So write firewalls policies as code. This is the proposal. Writing firewall policies as code give us a lot of good ideas if you apply the software-defined networking perspective, because you can abstraction, you can have a lot of abstraction, you think only what you want. You don't have to think about vendors, about, okay, I have a FortiGate, a Cisco, Palo Alto, some of my infrastructure is in AWS. Don't think about that. So be declarative, express your infrastructure security needs as user intents, and write the firewall policies where you need. Be free. So apply shift left is what DevSecOps says, okay? What is the most left? The application manifest. When I define in my application and the infrastructure that my application needs. Well, it's fine, it's a good idea, more or less. I think that is a good idea. But I need tool support for this, because if you have no tool support for this, it's difficult to scale to reduce the bottlenecks that we have seen before. So for the best of my knowledge, and I'm not here, I think that IntelliMent could be a good solution. So this is the pipeline proposed. The application owner define the application manifest and define what they provide and what we want to consume. There exists an entity like policy engine that consolidates what the risk team says, that is, it's not testing, it's not say, okay, you want this, I'm going to test that. No, he said, this is the things that are okay. The SecOps team said the CMDB, what happened here, and there exists a pre-approved flow that pushes into the network. So let's see an example about this. I'm going to use Puppet for define the application manifest, PuppetDB as CMDB, and the rest of the team is going to be IntelliMent and going to push on these devices. So with Puppet, we can define as code all what they need, and we are going to validate, deploy, and visualize on IntelliMent. Well, the Puppet code that we are going to provide is an extension into the Puppet definition that says what we have previously said, what we consume and we want to provide, okay? And it's all abstraction as you can. You can define IPs, you can define profiles, roles, etc. This is the example overview. This is a huge network. We are going to put an application of the front network, sorry. All the things have to have communication with this in several services. This is what we want. User needs HTTPS to the web server needs MySQL, all servers use DNS, and system administrator needs SSH, okay? Here's what we need. And here, I don't have any idea what is behind this, how many firewall are going to apply this. And this is what the risk team said. The risk team said, hey, okay, but you have encrypted HTTP flow, okay? You only have to have 443. So we define in the application definition by means of profile what we provide and what we consume for each element, like this. For example, web server that provides web services and database services are defined there, and using a very abstract layer, like my sources are internet and users. I don't know where they are. I don't know their IPs, nothing. And I provide as SSH and DNS, this other one, TCP/22. See that this application is providing a service by 8.0, and the risk teams say that this is not allowed, okay? So in this application, we see an example from clarifying concepts about what is on my network. This one are the pre-approved flow defined by the risk team that cannot be contradicted. And here I'm saying, okay, but I want to contradict something like here. So what happened? It's an error, and it is validated on a development stage in a software component. It's not validated on production when there is the risk. So this is not allowed. The risk teams has no ticket about that. It's automatically validated, and it's rejected. Application owners say, okay, I have to do only one simple change. I have to move to 443, and it is all okay. So before we have this, and now with this approach, we have this. My application owner have defined the manifest. The risk team has all automated, okay, because he has pre-approved flows defined on a CMDB, okay. It's automatically approved, automatically validated, and IntelliMan makes the automated change and the test, okay. So we go from something with bottleneck to something that doesn't have bottleneck, okay. So in 1 minute, I'm going to show you a brief demo of what we said. This is IntelliMan. IntelliMan is just an application on the top of a controller. Define a software-defined networking solution. So we have here an example. This one. Okay, this is the huge topology that we have seen before. And in my security diagram, I'm going to filter for what I want. I doesn't have to see all. I only want to see what is related with my application. And this is what we see, okay? And the red lines are the things that the risk teams have denied. So I get here PappetDB with my application manifest. I choose the scenario DevSecCon. And it is consolidating what is on the PappetDB and what is on the scenario, what is on the whole network, okay, in a declarative way. It doesn't matter about any firewalling. And gives me an example. It could be automatic, okay? It could be, it's only just for clarifying. And just an example, out of time. And I finish. I'm going to put this one. Oops, here. And it is automatically going to IntelliMan, going to the CMDB, and checking that it is consistent and has no breaking the rules. Okay, so let's see what they say. Oops. okay, I get a 443 and it's allowed, so I can apply it, okay? And it has to be applied on the network. So, final remarks. Imposing controls is fine, okay, and using workflow ticketing system is good, but introduce a lot of bottlenecks. So from a DevOps perspective, reduce your workflow bottlenecks as soon as possible, and work together to define what you need, not thinking about how to do that. And with good tool support, you can reduce your bottleneck into the network delivery. So thank you so much for your attention. If you have any questions. No questions.
Must have been really clear then.
Well,
thank you very much.
Thank you.